Good morning, everyone. The lead code question for today is tone game, and we have solved this using game theory, in which we have a base case here, which basically means if I had that particular ith element left only, then I would have to choose that ith element, element at index I. So that's why I have assigned dp of I with piles of I. Now my question says, now I've calculated, using bottom-up approach in where I have started from length 2 and I've calculated the start index, which is I, and n index j. So for any, any array in between range I to j, I have two choices. I can pick I or I can pick j. If I pick I, what happens? My opponent is left with I plus 1 up until j. And my dp of I plus 1 up until j is of size length minus 1. So my dp of I plus 1 will give me the value for that. And similarly, if I pick piles of j, my dp of I until j minus 1 would be my opponent's score, whatever is the optimal solution in that. And my dp of I will store that. Why? Because dp of I has the length minus 1 value here. So that what I mean to say is, let's say this is my I is my start index and j is my end index for any subarray. Now, like I'm starting my length from 2. So which means that if like let's say I have an array of length 2, if I pick any single element, I am left with the remaining element. And to choose this, I just need to get dp of I, because my dp of I basically suggests that um, this is the optimal result from I to length and previous length. So yeah, optimal solution of this. So yeah, this is the entire thing here, and we've submitted the solution. We have checked if Alice can win. So if Alice can win, we have returned true. And why we're minusing it, because the thing is we've used game theory intuition that if let's say Alice gains this profit, so it would whatever is the score of the opponent, it would lose that advantage. So that's why we've minused it here, and we've taken, since they play optimally, we've taken the maximum of this. And since Alice goes first, so that's why we've checked dp of 0 is greater than 0. Now, this solution is big O of n square time complexity and big O of n space complexity. And we want to see if we can optimize this. So in order to check if we can optimize this, what have we done is, like, let's say we are given some things here. The thing is that there are even number of piles. So if there are even number of piles, let's say I have 0, or let's say 1, 2, 3, 4, 5, and 6 piles. So I have 6 piles. There are even number of piles. And each pile has a positive integer number, and the total sum of stones across all the piles is odd. So which basically means if the sum is odd, it means that one sequence is greater than the other sequence. They cannot be equal, right? So let's say there are some at odd indices has indices will either be equal to or less than equal to sum at even indices. Now, since Alice goes first and they're playing optimally, now see, what is my sum at odd indices? Let's it will be 1, 3, 5, correct? And what will be my sum at even indices? It will be 2, 4, 6, correct? Now let's say in our case, the sum at odd indices is more. So what can Alice do? So let's say my Alice now wants to pick up odd indices, right? So let's say she goes and picks up 1. Now now Bob is left with 2 and 6. Both are odd indices. Now Bob has to pick an odd indice. So when Bob picks an odd and dice from either end, again Alice is exposed to the odd and dice when Bob picks even and dices. So anytime, since Alice is playing optimally, she will pick in such a way that, you know, she gets the majority sum, either odd or even in dice. So in either ways, see, because if this is odd and this is even, so she can choose whether she wants to go with odd or whether she wants to go with even. If she goes with odd, the other person has to choose between any two events. If she goes with even, the other person has to choose between any odds. So at any point, she always will have an option to go with odd, and the other person will only have an option to go with even or odd. She can control the game. So that is why she will always win. So that's why we return true. And when we submit the solution, the test cases I see as have passed, and I'm submitting this. I hope it will get accepted with my time and space complexity being big O of 1, which is constant. So yeah, that was it from my end. Thanks for watching. Bye.